The next step is to begin building your Volumetrics object. Return to the Insert STK Objects tool. Select Volumetric as your object. Insert Default as your method, and click Insert. Save your scenario. The first step is to create a simple cartographic grid that is going to be constrained by your area target. To do that, we need to open the Analysis Workbench. Right-click on STK Volumetrics and select Analysis Workbench. At the top of the Analysis Workbench, select the Spatial Analysis tab. In the Objects list, on the left, highlight Operations Area, and then go to the toolbar, and the third icon down called Create New Volume Grid, click that icon. At the top of the Add Spatial Analysis component window, you can see that the type is currently cartographic. That's what we will use in the scenario. Change the name to Simple Cartographic. We will keep the Constrain Active Grid Points within Area Target enabled. Click Set Grid Values. On the right, in the Altitude field, change your minimum altitude to 160 kilometers. Change your maximum altitude to 2,000 kilometers. Change your number of steps to 20. We are going to look at our volumetrics from 160 kilometers to 2,000 kilometers, and then click OK. Click OK again to close the Add Spatial Analysis component window. Save your scenario. In the Object Browser, right-click on your volumetric object and select Properties. We're going to view the simple cartographic volume grid to give you an idea of what you just built. So click the ellipsis button to the right of Volume Grid. In the Objects list, select Operations Area, and on the right, in the Volume Grids for Operation Area, select Simple Cartographic, and then click OK. Click Apply to make your change, and bring the 3D graphic window to the front. If you zoom out, you can now see the volumetric grid in your area target from 160 kilometers altitude to 2,000 kilometers altitude. Now we will create a constrained grid. I'm going to the bottom of the screen and click on the Analysis Workbench tab to bring the Analysis Workbench back to the front. Ensure the Spatial Analysis tab is still selected. Make sure in the Objects list, Operations Area is selected. Go to the toolbar and click Create New Volume Grid. At the top of the Add Spatial Analysis component window, for Type, click Select. Change your volume grid to a constrained grid, and then click OK. Give the grid a name, such as Sensor FOV. That stands for Sensor Field of View. Our reference grid is going to be the simple cartographic grid that we created a minute ago. Click the ellipsis button for Reference Grid. Ensure Operations Area is selected in the Objects list, and in the Volume Grids for Operations Area, select Simple Cartographic, and then click OK. In the spatial condition field, to the right, click the ellipsis button. In the objects list, select the sensor. In spatial conditions for your sensor, select visibility and click OK. We are going to apply our sensor visibility, which is being blocked by the terrain in the area, to our simple cartographic grid. Click OK. Return to the volumetric properties, which I still have up at the bottom of the screen. Ensure that you still are located on the basic definition page. The first step is to change the volume grid to our new constrained grid. Click the ellipsis button. Ensure operations area is selected on the objects list, and in the volume grids for operations area, select sensor FOV and click OK. Next, we will add a spatial calculation. So enable spatial calculation, and to the right, click the ellipsis button. In the objects list, select operations area, and in the spatial calculations for operations area, under installed components, select altitude and click OK. Apply your changes. Save your scenario. In the object browser, select Volumetric, return to the menu area at the top of STK and click the Volumetric menu item, and then select Compute. In the lower right hand corner of STK, you will see a progress bar. When you're done computing, the progress bar will disappear. Drop down to the 3D Graphics grid page. At the top of the page, disable Show Grid, and then click OK. Close the Analysis Workbench. And you can see the calculation of your grid. What we will do next is we will add layers to the grid, showing us how our grid is being blocked by the terrain in the area. So return to the object browser and open the properties of your volumetric object. Drop down to the 3D Graphics volume page. At the top of the 3D Graphic volume page, enable the Spatial Calculation Levels radio button. In the lower right side of the GUI, click the button Insert Evenly Spaced Values. In the Insert Evenly Spaced Values pop-up window, change your start value to 160, change your stop value to 2000, and change your step size to 200. As you can see at the top, the units default to kilometers. Go to the bottom of the pop-up window and click Create Values. Apply your changes. Now we will create a legend that will be embedded in the 3D Graphic window. So go to the 3D Graphics Legends page. Ensure Fill Legend is enabled, and then click on Show Legend. In the text options field, for title, I will give it a useful title. In this case, I will simply call it Altitude, and then in parentheses, km 4 kilometers. I do not require number of decimal digits, so I will change that value to 0. Go down to the Range Color Options field, change the color square width pixels value to 60. And then click OK. In your 3D graphic window, you can see your volume graphics. You can see where your volume is being interrupted by your terrain in the area. And as you get higher, you don't have any losses. Of course, you would want 100% volume coverage, but in this case, let's run a report to see how much volume we actually have. Return to the object browser, right-click on the volumetric object, and select Report and Graph Manager. In the Styles list, make sure Show Reports is enabled, and then select the report called Satisfaction Volume, and then click Generate. As you can see, I have approximately 96.3% satisfaction, so I'm missing a little bit less than 4% of my volume. When you're finished, you can close the report, and you can close the Report and Graph Manager and save your scenario.